Hello बच्चों, सत श्री अकाल and namaste from my side. How are you all? So this was a bike sequence regarding, right, explaining the concepts of motion in 1D. Yes, we are talking about the kinematics, right? We have seen the PW headquarters. Okay, so guys, this kind of things will always come upon, right? So show your support towards this lecture, especially for the teacher, and share it maximum if you really liked it. Okay, guys, sorry for this stuff. So this is your own physics educator Indrajit Singh welcoming you all into the most sensible platform for an aspirants, those who are preparing for JEE NEET kind of examination, and a very warm welcome for all, right, into the victory badge. This is a one-shot lecture on the motion into the 1D. Okay, lots of concepts we are going to see within it. Lots of concept, right, we are going to see within it. What kind of the concepts, right? What kind of the concepts? Lots of things are going to come, right? See, before moving on to this part, I want to tell you all about some things we are going to deal with. Just hold on. The fundamentals part. See, basically this whole chapter is entirely about the three kind of motion. First one is uniform motion. Second, that is a uniformly accelerated motion. And lastly, it is a non-uniform motion, but there are some, what do you say, the least cases of the non-uniform motion. And apart from that, right, one concept that is common in 1D and 2D, that is relative motion. Okay, so this thing we are going to see in today's lecture. Okay, fundamentals, uniform motion, uniformly accelerated motion, graph based on this concept. Okay, and the concepts of relative motion into the 1D, graph based on this concept. Spatially, we are going to have, right, 30 to 45 minutes for the to understand the concept of graphs and their respective graph conversion. The JEE and NEET exam, I'm sorry for this. The JEE and I'm sorry, extremely sorry. Okay, the JEE and NEET examination, okay, holds the prominent position. Okay, even this topic, if I'm talking about the graph conversion, right, then they holds high weightage in examination and having the highest possibility to come up in to the paper, right? So this kind of things we are going to discuss it today. So shall we begin? Yes or no? Shall we begin? Okay, so shall we begin? Okay, so let's start with see, the chapter starts with a very simple concept, right? The concept of motion. What does it states? Okay, and before moving on to the motion, I want to tell you all one thing. Okay, from now onwards till gravitation, like 1D, 2D, NLM, work energy and power, and slowly we'll move on to the rotation and gravitation. Till gravitation, we are going to deal with the two branches of the physics. We are going to deal with the two branches of the physics. The one that is kinematics, the second one that is a dynamics. So we are going to deal with the two branches, right? This is the first one, that is a kinematics. Second, that is a dynamics. Kinematics, if I am talking about, see, this entire chapter is kinematics. It is the study of the motion, right, without cause, with cause. Without cause, no involvement of force, no involvement of energy, right? Okay, nothing, no involvement of friction, no resistive, no distributive forces I'm talking about, right? So this entire chapter is completely based on the kinematics. Kinematics, in another sense, everything will be without cause. I am the observer, you are the observer, you are analyzing the motion and everything, it is going without cause. we are just analyzing. In the question, if data is given, object is moving from this point to this point, yes, we are accepting, right? We are not right, we are not getting worried about it. We are not understanding what is the logic behind it. Yes, we will crack the logic behind solving the sums, right? But we are actually not dealing with the force. Okay, so that is a difference. This difference you should all be aware of at this point of time. You should be aware of. Okay, so basically kinematics without cause, dynamics with cause. With cause, it means we are going to deal with the force, right? We are going to deal with the energies, right? Okay, the work energy theorem and lots of things. In another sense, we are going to study the cause of the motion and its respective applications, right? The cause of the motion and its respective applications. So this is the very basic thing that I want to discuss with you all. Now let's move on to, so in this entire chapter, okay, at any point of time, if any student is having the doubt in their mind, why this sort of thing is going on, why acceleration is acting like this way, why value of acceleration is getting changed, so the answer for all of those doubts is only one, and that is we are dealing without cause. We are only analyzing the motion. So in that case, whatever the parameters, whatever the situation it is given, we have to accept it and we have to try to find out the way to reach out the solutions into the numericals. Okay, so what is a motion? Right, what actual is a motion is? This is a day-to-day right example, car on a road. Is it a motion? Sir, it happens. It completely depends whether you are inside the car or whether you are standing on the ground and analyzing the moving car, or sometimes it also depends, right? On what thing it depends. Some students might be saying, yes, the car is on the road. I am saying the car is moving on the road, right? See, this is having the two meanings. Car is on the road. So is it stationary on the road or is it moving? For a person who is standing on the ground, there is a possibility that car may move with some specific velocity. But, right, for the same person who is inside the car, right, okay, the car appears to be at rest with respect to that person. So for someone, car is in motion. For someone, car is at rest. So practically we can't say anything. Why we can't say anything? Because everything depends on what observer is observing in the phenomena. Again and again I am saying, mark my words. Everything depends on what observer is observing in the phenomena. But if we want to, in generalized form, if we want to, from the kinematics point of view, if you want to define the motion, then we can say that, right, change in position of an object with respect to time, and actually your word observer surrounding should come, but I am saying observer, right? I am saying it an observer. Why? Because this hold the most prominent position. Everything is with respect to observer and with respect to time. Everything is with respect to each and every motion is analyzed with respect to observer. Okay, observer changes, things may get changed. Observer position changes, right? So here I gave you all an example. The car is on the road. With respect to the person who is inside, right, it's stationary. Okay, for him the surrounding environment is moving. For the person who is on the ground, who is analyzing the motion, for him the car is moving. So we are with the two observers, na? The first observer is on the ground. The second observer, he's inside it, the car. So things always get differs if the position of the observer gets changed. If the, in another sense, if I want to note it down, you want to deliver it technically, if the frame is getting changed, things are getting changed. The frame is getting changed, the things are getting changed. So everything depends on frame of reference. Right, everything depends on the frame of reference. What actual the frame of reference is, right? What actual the frame of reference is. Lots of technical definitions are given into the thousands of the books, but I want to deliver it into the, right, I want to deliver it specifically, okay? And I always used to say in all of my sessions that whatever the things that are easily understood by you all are always represented, rather than, okay, rather than to move on to the quite complex approach. These things, whatever the definition I'm going to write within few minutes, it will be quite easily understood by you all. Apart from that, see, understanding the concept, it is important, okay, rather than to move on to the grammatical formations, right? If it is in your mind, okay, you can even write it down, and you can even you will not face any kind of the problem while analyzing the multiple resources, right? So frame of references, frame of references. So if we're going to simply define this term, the frame of references, I'm going to define it as the point from which observer takes its observation. This point can be any position in 1D, right? Can be in 2D, can be any 3D coordinates, right? This point can be any point at any position into the entire three-dimensional space. Again, we are coming back to our same example, a car on the road, right? A one point is the person who is standing on the ground and analyzing the motion. The second point is the person who is actually inside the car. Things may get different, na? Right? So, the frame of reference, the point from which observer takes its observation. Simply, as I said, I have not given you that much technical approach, but simple it is needed. Frame is getting changed, things are getting changed, motion is not getting changed. Motion will get changed technically because things may get differ. And according to that, you are going to apply those specific concepts into the numericals. Right? So, frame of reference. And one thing I want to write it down here, right? And that is nothing in a universe is in absolute motion while nothing is at absolute rest. Does Earth appear stationary to you all? Why? because you all are inside the frame of reference. With respect to moon, earth is not stationary. With respect to sun, earth is not stationary. With respect to Mars, earth is not stationary. Right? Even the situations are not same while analyzing the earth from Mars and while analyzing the earth from Saturn or Pluto. Right? Okay, so everything is a frame of reference. Nothing in the universe is at absolute rest. We can't define that from all frame of references. See, absolute rest, it means that in the entire universe, right, from all frame of references, from all positions, right, it appears to be stationary. Is it possible? No. Is it not? It's not possible. Right? So for that reason, nothing in the universe is at absolute rest. Similarly, absolute motion, it means that in the universe there exist all coordinates, all points, right, from which the observer is observing and they are getting the same results. Same results, it means the person who is standing on the road and analyzing the car is also having the same output as compared to the person who is inside it and you can say the inside it and it is driving the car. Is it so possible? No. So nothing in the universe is at absolute rest, right? Nothing in the universe is at absolute motion. Okay, now basically we are having the two types of frame of references. The first one, that is an inertial frame of reference, right? The second one, that is in a non-inertial frame of reference. Now, before moving on to this concept, inertial and non-inertial frame, I want to clarify, right, a thing that from now onwards, whatever you are going to analyze, you are going to be the observer. Why you are all going to be the observer? Because things are going to appear in front of you all. You are going to analyze these things. It means you are the observer. So whatever the frame, right, you are holding, okay, that will be the truth. You have to analyze all of those concepts through that frame. Okay, you have to analyze all of those concepts through that frame. Inertial and non-inertial frame of reference. Right. So from now onwards, observer is in the specific frame. Right. When, right, when the frame velocity is 0 or when the frame velocity is 0 or the observer is moving with the constant velocity. When the frame velocity is 0 or the observer is moving with the constant velocity, right, then we can say that. What is an example of it? Okay. This is a cart. It is moving with some, right, velocity. Let's say it's constant, but here this is an observer. This is the position of the observer. Observer is stationary, velocity of the observer is 0. Then I must say he is in the inertial frame. Second, cart is moving with some velocity v1. Observer is also moving with some velocity v2. v1 is also constant. v2 is also constant. So in that case, this frame is also inertial frame. Right. Values may get differ. Right. Outputs may get differ. Values may get differ. Outputs may get differ. Right. But the one is an inertial frame. Right. The frame velocity or the velocity of an observer is 0, is stationary, or the velocity of the observer is constant. Let's move on to the next part onto it. Right. The second, this is an inertial frame of reference. Now let's move on to the non-inertial frame of reference. When the frame velocity is continuously increasing or decreasing, right? Frame velocity is continuously increasing or decreasing with respect to time. Continuously it is getting increasing or decreasing with respect to time. Let's analyze this stuff, right, of the non-inertial frame. Right, let's analyze this stuff of the non-inertial frame. Okay, the cart is moving with the constant velocity, but the observer who is on the ground, right, his velocity is continuously increasing with respect to time, right? Observer velocity increases with respect to time. Right. Inertial frame of reference, non-inertial frame of reference. Right. So this was all of those basics of the the motion. Okay. Now sign convention. See, this is a very problematic case because in some of the schools, right, they are taking the downward direction as a positive, right, and upward direction as a negative. And while in some schools, right, they are taking upward as a positive and downward as a negative. I'm going to tell you all the general sign conventions that we are going to use till end of this course, this end of this victory batch. End of this victory batch, till end we are going to use that stuff. Sign conventions, right? This is x-axis, this is y-axis, this is z-axis. The same thing we are going to use till end, right? So remember, vectors you all are aware of. Vectors you all are aware of, right? Vectors means a very simple thing. Suppose a vector of a physical quantity is directed upwards, we are going to take it as a positive j. So it means upward will be positive. If vector of any physical quantity is directed downwards, we are going to take it into the negative j. It means whatever the vector, right, that are directing into the downward directions are considered as negative. The vector that is directed towards the positive x direction, right, I will consider it as a positive I. It means whatever the vectors that are directing towards the right will be positive. Right, and the vector that is right moving into the right that is directed towards the negative x direction, right, I will consider it as the negative I, right? So whatever the vectors they are directed into the negative direction towards this side, they will consider as a negative. Similarly, that exists for the z also. This side it is positive and the opposite side this will negative. But here right now we are only dealing with the motion in 1D, in the kind of the rectilinear motion we are dealing with. Right, okay, so we are only moving on to, we will only consider x and y. Upward positive, downward negative. Okay, so in some of the schools it is discussed, or some of the right institutions it is, they always used to take downward as positive. But just keep this thing in mind, everything is with respect to the reference point, right? Okay, without a reference point we can't analyze the motion. Okay, as like things always get changed with respect to the observer. Similarly, if the reference point is getting changed, things always, the parameters of the motion always gets changed. The reference point is getting changed, the parameters of the motion always gets changed, right? So everything is with respect to the reference point, and the reference point of the motion is t is equal to 0. Generally, in maximum number of the cases, when observer starts analyzing the motion, we can say its t is equal to 0. Yes, I started. He might have started from Mumbai, but I met him at Surat. Right. So at t is equal to 0, I have met him. So it is possible that object might be running since Mumbai, and even he had covered, or the object is covered distance till Surat also. But I started analyzing from Surat na. So for that observer, it is t is equal to 0. There is a possibility that you may start from t is equal to 0, but observers may get differ. So what observer is thinking, the moment at which observer tries to starts to analyze the motion, things are fixed. That is a reference point, and that reference point is always considered as t is equal to 0. Right. So for the sign conventions, right, it is clear for you all. From now onwards, we are going to take upward as a positive. These are the generalized sign conventions that we are going to use till end of the physics. Apart from this, okay, two more sign conventions will come. One will come into the rotational motion, clockwise and anti-clockwise. The second will come up into the magnetism, into the 12th part, right? The inward and outward. But that inward and outward is also part of the z-axis, right? This is the third dimension, the z-axis. Okay. So only apart from this sign conventions, only two new things are going to come. One will come in rotation and second will come into the syllabus of 12th. Right. So these are the sign conventions. Let's move on to the next part, the fundamentals. Okay. Position. Now the motion starts. Right. As I used to say, lots of technical definitions of the positions are mentioned. Okay, but I want to move on to the very simple thing. I want to move on to the very, very simple thing. Right. What is the position? Okay. At a specific the one who understands this statement will get the definition of the position. At a specific time instance where the object is. At the specific time instance where the object is. At t is equal to 0, I started my motion with respect to some observer from home. At t is equal to 0, I started the motion with respect to some observer on home, from home. Slowly it started, right? So from t is equal to 0, it started. What is the, I want to reach up to the office. It will take approximately 1 minute. Let's say 1 minute. What is the position of the object at t is equal to 5 seconds? What is the, I can't say what is the position. Right, if I start from t is equal to 0, right, from home, then I must say where I reached at t is equal to 5. First of all, t is equal to 0 will be my reference point. This may get changed, but generally in maximum number of the question, t is equal to 0 is taken as the reference point. There exists one question in NCERT, right, in which the reference point has changed. Okay, time is considered as the negative. Okay, but that thing is conceptually correct also. Don't get worried. Okay, but maximum number of the cases says this. So from t is equal to 0, right, this is a reference point and things may get stuck. Right, now I'm in the continuous call with my colleague. After 5 seconds, where are you? Oh yeah, I have crossed this 7th street. After 25 seconds, where are you? I have crossed this blah blah signal. After 40 seconds, where are you? After 45, where are you? After 55, where are you? After 60, in front of you. So at a specific time instance, what is the position, at what specific time instance where object is will define the position of the object with respect to the reference point. At t is equal to 5, this is the position of the car. At t is equal to 20, this will be the position of the car. At t is equal to 30, this will be the position of the car. At 3 is equal to 40, this will be the position. At t is equal to 50, this will be the position. So at the specific time instance, right, where actually the object is located with respect to an observer. At specific time instance, right, actually where object is located with respect to the specific time instance will define the position of the object, right? This in 1D it is a position, in 2D it is a coordinate, right? Okay, when object is moving into the plane. Okay, this will come up into the next chapter, right? Okay, now let's move on to the next. After this position, now we are dealing with the parameters of the motion. The first parameter is a position. The second is the path length. Now what actual the path length is all about? What actual the path length is all about? Right. Path length. First of all, let's understand the example of the path length. At t is equal to 0, this is our reference point from which, right, observer or object start its motion and observer is analyzing. Suppose here is an observer, okay, at t is equal to 0, he starts analyzing the motion. At t is equal to 0, he starts analyzing the motion. What is the path length? It doesn't matter how you are going. Suppose he starts from A, it reaches to B, then he moves on to the C, then he again moves on to D. At t is equal to 0, motion started. At t is equal to t, motion ends. So what does this path length states? The total distance covered into the motion. Is defined as path length. The total distance covered into the motion, it is defined as the path length. So here what will be the value of the path length in another sense? A of B plus B of C plus C of D. Now students are in a chaos. Sir, what is the actual difference between the path length and the distance? This you told us, na? The point from where, like the point from which motion begins to the point it ends. The point from where the motion begins to the point where it ends. The total distance covered, maybe it is on the circular path, we are going to consider as the distance only. Okay, and that thing will be get clear while solving up the sums. Okay, that thing will be clear by solving up the sums. Okay, so at t is equal to 0, motion started. At t is equal to 0, the motion started. that until now, until end of the motion, the total amount of the path distance covered. Now, what is the distance and what is the difference between the path length and the distance? Right? What is the, okay, see. This is the path length. Now, what is the distance? Distance can be on between the any two time instances, right? Distance can be in between while path length is for entire motion. Distance is in between the 2 points, while the path length is for the entire motion. What is the distance covered between t is equal to 0 to t is equal to t1, the 2 time instances? I must say the distance is AB. This is not the path length. Path length is entire distance covered into the journey. And distance is what? Okay, it is a specific, it can be in between the 2 time intervals, right? It can be for the entire journey, right? It completely depends. So this is the actual difference, right? Yes, I'm talking about the difference between the distance and the path length. A micro thing that might not have delivered, right? But I'm telling you in front of. Generally, the displacement, it is the shortest path, right? The displacement is the shortest path. Examples: point A, point B. If you are moving onto the curve, right, AB, that is an arc. AB, that is an arc. I can consider it as a distance. I'm not saying it is a path length, it is only the distance, right? But if I'm talking about the displacement, the straight line is the displacement. The straight line is what the displacement is, right? Let's see some of the sums, right, based on the distance and the displacement to clear out the concept, right? A man goes 10 meter towards north, then 20 meter towards east, then the displacement is what? Displacement is the shortest distance in between the 2 time intervals or in between the initial and the final point of the motion. Displacement is the shortest distance between the 2 point, right, or between the starting and the end point of the motion. Yes or no? Okay. So here, let's move on and let's analyze this thing. I'm having the isometric view. This is north, this is south, this is east, and this is west. A man goes 10 meter towards the north. Then 20 meters towards the east. So whenever you get confused, again draw the convention here. This is north, this is south, this is east, and this is west. Now he is moving, right, 20 meter towards the east. This is a 20 meter. So this is the final point of the motion. This is the initial point of the motion, right? Okay, this is the displacement. The displacement is what? Directly, if we are going to apply the Pythagoras theorem, then it is under root of 20 square plus 10 square. This will be the displacement, right? That is equal to under root of 500. So that is equal to under root of 10 root 5, and this is nearly equivalent to 22.5 meter. What is the distance covered? 10 plus 20, 30. What is the displacement? 22.5. Sir, this is very easy, huh? It's not fair. A body moves, let's come to the fair sums. A body moves on 1/4 of the circular arc in a circle of radius r. The magnitude of the distance traveled and the displacement will be what? Body moves over 1/4 of the circular arc. Let's say this is an initial position and this one is a final. This is a circular arc. Right. First of all, if I'm talking about the distance, so that will be arc length. That will be arc length. For the quarter part of the circle, see, it is defined as theta dot r, where r is the radius. For quarter part of the circle, the theta is defined as pi by 2 into r. So this will be the distance covered. Right? This will be the distance covered. What is the magnitude of the displacement? Shortest distance between A and B. R root 2. R square, R root 2. Right. So distance travel is pi r by 2. Displacement is r root 2. The A is the perfect answer. Sir, so quite simple sum. You're not showing us the complex one. The displacement of a point of a wheel initially in contact with the ground, when the wheel rolls forward, half of the revolution will be what? Point is at this position initially, finally after half rotation, half of the rotation, it means, right, the arc length cover, the total distance covered is pi r. Why? It is theta into r. For half of the rotation, theta will be considered as pi, right? So that's why this linear distance covered between the 2 points into the half. I'm talking about the distance, not path length. Right? How we are going to solve this sum? Okay. Again, to solve it up, I'm giving you all the 10 seconds, right? Okay. On the countdown of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's it. Okay. You can pause the video and answer the specific question. This is the radius 2r. This is the distance covered pi r. Can we say this is the between initial and final point? This is the displacement. Can we apply the Pythagoras theorem? Right. On applying the Pythagoras theorem, finally we are going to get the displacement. So the displacement that is equal to, right, okay, under root of pi r whole square plus 2r whole square. So this is under root of pi square r square plus 4r square. So this is r under root of pi square plus 4. This is the displacement on completing the half revolution between the 2 points. On completing the half revolution between the 2 points. Right. Let's move on to the next parameter of the motion. See, 6 of the parameters we are going to discuss: speed, velocity, average velocity, instantaneous speed, and instantaneous velocity. Okay. Rather than to have the individual discussion on the specific motion parameter, okay, I'm going to show you all the 3 differences. The first will be the difference in between the speed and the velocity. The second will be the difference in between the the speed and velocity. The second will be in difference between the average speed and average velocity, and the third one in between the instantaneous speed and instantaneous velocity. Okay. To have the individual discussion on that specific motion parameter is going to consume the lots of time, rather than, okay, these differences are going to help us a lot. Speed. The speed velocity, sorry, it is a distance covered by an object per unit time. It is always positive, or it can be 0. Distance covered in a specific time. Distance covered into the specific time, while the velocity is displacement into the specific unit time. This can be positive, this can be 0, this can be negative. Speed is always positive. Velocity can be positive, velocity can be 0, velocity can be negative. It completely depends on, right? As I told you all into the distance, distance is always positive, right? Okay. Distance is always positive. Displacement, right, can be positive, can be negative, can be 0. Similarly, on basis of this data, right, okay, on basis of this data, speed is always positive. SI unit is meter per second, SI unit is meter per second, having same dimensional formula. Speed is associated with distance. So as it for those reasons, it is the scalar quantity. But velocity is associated with the shortest distance. Speed is associated with the distance, but the velocity is associated with the shortest distance. So this shortest distance can be at it can direct in any way in the entire 3-dimensional space. It can direct in any way in entire 3-dimensional space, right? Okay, so for that reason, it is a vector quantity. Okay, so using this 3 to 4 terms, it is easily, right, we can easily define. Now, what's an average speed? The difference between the average speed and average velocity. Total distance in specific time interval. It is defined as the average speed. Or average speed is always positive, or sometimes we can have it value as 0. Average speed is always positive, or sometimes we are having the value as 0. Average speed, or you can say average velocity, displacement per unit time. Now, what is a difference between speed, velocity, average speed, and average velocity? Speed and velocity can be, it is not for sure, right, that speed and velocity are only defined for entire path. No, it can be in between any 2 instances, while the average velocity and the average speed are defined for the entire path. That's why the word average is used. Net displacement to the total time. So if we are talking about average speed and average velocity, it means we are talking in between the 2 time instances, from where the motion started and from where it is going to, till the point it is going to end, not from where. Okay, from where it started until the point it is going to end. From where it started until the point it is going to end. Average speed is a scalar quantity, average velocity is a vector quantity. Average speed of the particle is finite, it cannot be zero. Yes, practically it cannot be zero. But when the object is stationary, right, we can't define average speed. Okay, and it is only zero when it is at the rest. Okay, average velocity of the particle can be zero, can be positive, or it can be negative. Average speed is greater or equal to the magnitude. See, I am again highlighting this statement because on basis of this, right, sometimes the theoretical questions are asked into the examination. Okay, average velocity is a magnitude and it is always less than the speed of the particle. Okay, so this is a very simple explanation in between the average speed and the average velocity. Instantaneous. At what instance what will be the, see, at a specific time instant, what is the position of the particle? At specific time instant, what is the position of the particle? At specific time instance, what is the position? Blah blah blah. Like those things. Instantaneous speed and instantaneous velocity gives the value of speed and velocity. Suppose from t is equal to 0, the motion starts. At t is equal to t dash, the motion ends. In between, you can take any random instance. At that, suppose you start from t is equal to 0, like from your home. If you are having journey to Goa, obviously it is going to take more than 10 hours. Right? So at t is equal to 4th hour, what is your average? What is your speed? That is instantaneous speed. At t is equal to 5th hour, at that moment of time, what is the speed? What is the velocity? That is your instantaneous speed and instantaneous velocity. At that moment of time, how you are going to define that stuff? Right? So that is the instantaneous speed and instantaneous velocity. Generally, instantaneous speed and instantaneous velocity are defined, right, and more used in calculus method. Okay, generally they are more used into the calculus method. See, in the diagram it has been shown, right? In the diagram it is shown, suppose the particle starts its motion from t is equal to 0, right? At this time instance, the speed and the velocity are the instantaneous speed and instantaneous velocity. Right? Instantaneous speed is a scalar quantity. Instantaneous velocity is a vector. Can be, this is positive, negative, and all of those stuff. Okay. So these are the some of the motion parameters we discussed. Now let's move on to the sums, right, based on it. In 1 second, a particle goes from point A to point B, moving into the semicircle of the radius 1 meter. The magnitude of the average velocity will be what? Now see the average velocity they are asking, right? Particle is moving on from point A to point B. Average velocity they are saying. So average velocity, I must define it as, right, the net displacement by total time. In 1 second, it is covering the net displacement of, see, this is 1 meter of the radius. This is 1 meter. The total displacement is 2r in 1 second. So it is average velocity is 2 meter per second. Oh, I'm sorry. The motion of the particle is defined as this. The instantaneous velocity will be what? See, it's a very simple explanation. X is the position, bt square. The position of the particle changes with respect to this. The value, the formula of the instantaneous velocity is v instantaneous, that is equal to differentiation of the position with respect to time. So can I differentiate this equation with respect to time? Then I'm going to have dx by dt, that is v instantaneous. So that is equal to 2b of t. At what second? At 3 seconds you have to, right, at 3 seconds. So v instantaneous, right, at 3 seconds it is equal to 2. What is the value of B? Into 3 into 3. 3 3s are 9, 2s are 18. It is 18 centimeter per second. Instantaneous word, right? It is more used, right, into the calculus method, and that entire calculus method is like this way, dx by dt and all of those stuff, right? Now, directly we are going to move on to the classification of the motion. From now onwards, we are going to deal with the three kind. The uniform motion, right? The uniformly accelerated motion, the non-uniform motion. And apart from this, in all of those three cases, there exists the concept of the relative motion and motion under gravity. And this is one, right? Right? Motion under gravity. Okay. So let's start with the one of the right, uniform motion. Let's start with the right, uniform motion. What actual is the uniform motion? It's a very simple definition, and the entire concept is based on only one formula. Uniform motion. A very simple concept based on single formula, right? So I must write it down without wasting the time. If I want to define the uniform motion, then equal distances in equal time intervals. Equal distances in equal time intervals. Let's take an example. The object starts from A, ends at B. Right? Object starts from A, ends at B. This is a first time interval T1, this is T2, this is T3. Right? So from 0 to T1, the distance covered is D. Right, with the velocity v. Okay, d1 v1. Motion parameters may get changed, right? But the uniform motion states that from 0 to t1, 0 to t2, or in another sense from t1 to t2, t2 to t3. In all of those, the velocity of the particle is constant. Right? Instead of velocity, let's say speed is constant. And it is only based on the one simple formula, v is equal to, okay, speed is equal to distance by time and velocity is equal to displacement by time. Only one simple formula. This is only the simple concept of the uniform motion is all about. Right? Okay. On basis of this, see, only one question solving approach is there into the uniform motion. Okay. Maximum number of the questions are going to come on from the average speed. We are going to see. Okay. If I'm talking about the average speed, then we are having the right definition is total distance covered by total time. Total distance covered by total time. What is the total distance? D1, D2, D3. Suppose the entire path is divided into the n intervals. What is the total time? Then average speed is defined in this way. Suppose if the distance and the time intervals are not given, the velocity and the time intervals are given. Okay, then we have to use this formula. V1 T1 plus V2 T2 plus dot 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 plus Vn Tn, right, whole divided by T1 plus T2 plus dot 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 plus Tn. Suppose if you are not having any detail or the data about the time thing, okay, then you can have it like only distance and the velocity intervals are given. Then we can use this formula. It's d1 by v1, d2 by v2, it's dn by vn. So any among these three, depending on the whatever the data it is given into the question, we can directly use that formula into the specific question. Apart from this, in the case of the uniform motion, we are having some of the spatial cases also. Right? What are those spatial cases? First, suppose particle starts from A, ends at B, right? It covers the distances into the right two intervals, and those two intervals have the equal measurements. So we can define it as a case of equal distances. Suppose here for the first interval the speed is v1, for the second it is v2. Then what will be the average speed? So the average speed we are going to define it as, in this case we are having the direct formula for the equal distance interval, that is 2v1 v2 whole divided by v1 plus v2. Right, this is the formula of average speed. Second is an equal time intervals. Distance doesn't matter. Object starts from A, ends at B. For time t1 it is moving on with speed v1. For time t2 it is moving on with the speed v2. For time t1 it is moving on with the speed v1. For time t2 it is moving on with the speed v2. Yes or no? So in this case, how we are going to define the direct formula of the average speed? Right. So the average speed, it is going to be v1 plus v2 whole divided by 2. Right. So these are some of the important formulas that are used into the uniform motion, and the question based on this are asked into an examination. The question based on this are asked into an examination. Okay, let's move on to the first question onto it. A particle covers half of the total distance with speed v1 and rest half distance with speed v2. The average speed during the entire journey will be what? Okay, now we are going to see the proof of the equal distance interval case, right? I give you all the formula of it. Now we are going to see the proof. Suppose it starts from A, it ends at B. For the first distance D, it is moving on with the speed v1. For the second distance D, it is moving on with the speed v2. So what is an actual formula of average speed? See, only D and V are given. So directly we are going to take the formula d1 by d2 whole divided by d1 by v1 plus d2 by v2. Right, because nothing is mentioned, right? No data about the time intervals or the time things are given. Okay, so directly we are going to say it's d plus d whole divided by d by v1 plus d by v2, right? So from here d will get cancelled, and the average speed, right, it is going to come upon as 2v1 v2, right, whole divided by v1 plus v2. This will be the perfect answer for this specific question. A very simple proof. A car moves from X to Y with the uniform speed Vu and returns to X with the uniform speed Vd. The average speed for the round trip will be what? Same. It starts from X, it reaches to Y with the uniform speed Vu and it returns with the uniform speed Vd. It's moving distance d into the front direction, into the back direction. d into the front from x to y, and d coming to the back from y to x. Again, it is a case of the equal distance interval, so the average speed, it is going to come upon as 2 v of u v of d whole divided by v of u plus v of d. Right? D is the perfect answer for this specific question. A bus traveling the first 1/3 distance with the speed of 10, the next 1/3 at the 20, and the last 1/3 at the 60. What is average speed? Now this is a very simple. Now we are having the 3 equal distance interval. We have seen till now d by 3, d by 3, d by 3. Right? One with 10, second with 20, third with 60. Directly we are going to use the formula of the average speed. That is equal to d by 3, d by 3, d by 3. Whole divided by d by 3 v1, d by 3 v2 plus d by 3 v3. Okay, so this is going to be 3 whole divided by 1 by 10. How much it is? 10, 20 and 60. 1 by 20, 1 by 60. Right? So final, the average speed, it is going to be is equal to 3 whole divided by, right, 20 plus 10. Or in easy terms we can say it as 1 by 10 plus this is 60 and this is 3 by 60, right? LC of 1 by 20 and 1 by 20 into 3, sorry, 4 by 60, right? Okay, 4 by 60. I'm sorry for that, right? 3 plus 1, 4, 4 by 60, right? So this is gonna be approximately 3 whole divided by it's 10 by 60, 60 into 3 by 10, right? This is gonna get cancelled, right? Average speed is going to come upon as 18 km per hour, right? Average speed is going to be 18 km per hour. We are having the direct formula for the 3 equal distance intervals also, but rather than to move on to the quite complex approach, because right, by remembering the formula of the special cases also na, so by the end, right, you will have you will have that kind of psychology. We are having lots of formulas in physics. I don't want you all, right, to reach up to that position. So for that reason you have to just follow the general concepts, right, and things will get quite easy. A car moves at the distance of 200 meters. It covers first half of distance 40 and second half with V. Now see, first half with 40, right? Second half with V. Average speed, right? It is how much? 48 km per hour, right? So can write it at 48 is equal to 2V into 40 whole divided by, right, V plus 40. Okay. So 2 24s are, 2 12s are, 2 20s are, 2 10s are, 2 6s are. 6 by 10 is equal to V by V plus 40. 6V plus 240 is equal to 10V. 240, that is equal to 10V minus 6V, that is 4V. V, it is going to come upon as 60 meter per second. Sorry, it is kilometer per hour, right? It is kilometer per hour. B is the perfect answer for this specific question, right? Okay, B is the perfect answer from this specific question. Okay, from now, right, a new thing is going to start. That is the uniform motion is quite easy. Okay, it's not a big deal to understand the concept of the uniform motion, right? Things always gets changed and complex, right, when we are dealing with the concepts of the uniformly accelerated motion and the calculus methods, right? Uniformly accelerated motion and the calculus method. Okay, before moving on to the concept of the uniformly accelerated motion, let's understand what actual the acceleration is all about. The time rate of change of velocity, it is defined as the acceleration. Okay, the time rate of change, right, in velocity, it is defined as acceleration. Time rate of change of velocity. In another sense, if I want to write, then acceleration is constant, right, then I must say that is delta v by delta t is constant. Velocity is increasing or decreasing at the uniform rate, then I can say this as acceleration being constant, as else the acceleration is generally defined as delta v by delta t, change in velocity per unit time. We have seen the example, na? Suppose the object is starting its motion from t is equal to 0, right? Object is starting its motion, I'm sorry for this, right, at t is equal to 0. Now suddenly what happens, let's take an example. From a point it starts its motion, right, and it reaches up to point B. From a point it starts its motion and reaches up to point B. Now see, in first time interval the velocity is v1. Suppose it started from 0 and it reached to 10 meter per second in time t1. Let's say in another time t1 it reached to 20 meter per second. In the third time interval t1 it reaches to 30 meter per second. Into the fourth time interval t1 with respect to the reference point t is equal to 0, right, it reaches up to the right 40 meter per second. So at every, on the span of every t1 seconds, the velocity is uniformly increasing, right? Mark my words, uniformly. Velocity is uniformly increasing, then we can say acceleration is constant. Apart from this, if we want to define average acceleration, then it is change in velocity, right, for entire path by total time. Change in velocity for entire path by total time. Instantaneous acceleration, right, okay, at the specific instance of the time. Okay, acceleration at the specific instance of the time, the smaller time rate of change of velocity, right, at specific instance of time, the value of acceleration is instantaneous acceleration. The value of the acceleration, it is known as what? Instantaneous acceleration. So the general definition of the acceleration is a rate of a change of the velocity with respect to time. If this change of a rate is a uniform, acceleration is constant. It is positive if velocity is increasing. It is negative if velocity is decreasing. Average acceleration for entire path I am talking about. Let's say it starts from A ends at B. For entire path, what was the change in velocity with respect to the total time? That is average acceleration. Instantaneous from entire path, right? I started from t is equal to 0 from home. After 4 hours, I am going to reach up to Ahmedabad, right? Then what will be the value at Ahmedabad? What is the value at Surat? What is the value at Ankleshwar? What is the value at Vadodara? What is the value at Anand? What is the value at Nadiyad? That will define this stuff, right? That will define that stuff. Now here comes the, right, this was a simple definition of the acceleration. Now here comes the concept of a uniformly accelerated motion. The word itself states that object is uniformly accelerated. It is uniformly accelerated, right, or retarded. Object is uniformly accelerated or retarded. How? Let us take an example. Object starts from point A, it reaches to point B. This is time interval T1, this is time interval T2, this is time interval T3, this is T4, and this is T5. Right. In between, this is my reference point. T is equal to 0 from, right, object started its motion. This is my reference point. Right, from T is equal to 0, from where the object started its motion. This is my reference point. So what happens here? It's a very simple thing, right? Okay, the time rate of change of velocity here, it starts from 0, it reaches to V. Now it is going to reach to 2V. It is going to reach 3V. It is going to reach 4V. It is 5V. Or moving on from, let's say, suppose object, if it starts from A, it moves to B. We can say it is a case of acceleration. Why? Uniform acceleration. Why? Because the velocity is uniformly increasing with respect to time. But when we say from B to A, it is a case of the deceleration, or we can say it is a retardation. Why? The velocity is uniformly decreasing with respect to time. Right? It is uniformly decreasing with respect to time. So what is the case of the uniformly accelerated or the retarded motion? Right? In which the acceleration of the system is constant. Right? Okay, acceleration of the system is constant, right? It can be positive, it can be negative, it can be zero. Zero is not so possible, right? It can be positive, it can be negative, right? Okay, for positive it is known as acceleration, right? For negative it is known as retardation. Everything is physics, right? Everything is in physics is described in terms of mathematics. Everything in physics is described in terms of mathematics. Everything. Then how we are going to define this stuff? How we are going to mathematically represent this, right? For that, okay, we are having two ways. The equations, right, of the uniformly accelerated motion can be described in two ways. One, the method that is given into the NCERT way, using graph equations can be obtained. Right? Using graph equations can be obtained. Second, we are having the, right, the second method, right, okay. The second method, it is, the first one is an NCERT way, right? Okay. The second method, what we are having is the calculus method, the calculus way. First of all, I want to tell you all, the calculus method is not generally, it is not only for UAM. The UAM stands for uniformly accelerated motion. The calculus method is not generally for uniformly accelerated motion. Okay, it is for all kind of the motion. For all kind of motion, right, where the motion parameters, where the one motion parameters right, one motion parameter change depend on another. Displacement is depending on time, velocity depends on time, acceleration depends on time. Like these things are going on. Like these things, right, are going on. So whenever see calculus method is for all kind of the motion, uniformly, non-uniform, rectilinear, curvilinear, 2D, everything. Everywhere we can use the calculus. But this is the best way to define, best and another way to define the equations. Right. Okay. Generally, it is for very small change in parameters. Right. Question solving approach for acceleration to be constant, right? Okay, if we are directly moving on to the graphical method, we are having the first equation, v is equal to u plus at, s is equal to ut plus half at square, right? And v square minus u square is equal to 2as. Right? So here what is going to happen? With respect to the, everything is going on with respect to the reference point. Everything is going on with respect to the reference point. If you want to calculate velocity at any time instance, right? Velocity at any time instance, then we can say you can use this equation, right? Displacement with respect to the time, this reference point at any time instance, right? Or in between the two time intervals, right? Okay, and v square minus u square between 2. In any distance interval s. And suppose if we are moving on to the calculus method, in the entire calculus method, right, of the kinematics is depending on only 3 formulas. If we are not dealing with the cos, then entire calculus method is depending on only 3 formulas. Acceleration is dv by dt. Second, velocity is dx by dt, right? And the third one, that is equal to, okay, acceleration is dv by dx. Right? On basis of this thing, the entire calculus method is defined. So this is only the question solving approach for all of the kind of the questions. Right? I'm moving aside on the countdown of 10 seconds. If you want to just note it down, you can. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Particle, using those equations, we are going to solve that stuff. Particle starts its motion from rest under the action of constant force. Constant force, it means constant acceleration. The distance covered in first 10 seconds is s1. First 20 seconds is s2. See, it starts from reference point t is equal to 0. In first 10 seconds, it is covering the distance of s1. In the total 20 seconds, it is covering the distance of s2. And how we can say what is the relation between the s2 and s2? It starts its motion from rest, u is equal to 0. Constant force, see, those equations are only applicable, the equations of the uniformly accelerated motion are only applicable in the cases, right, where the acceleration is constant. So here it is mentioned that acceleration is constant. Directly see this, the relation between the time and the displacement, it is mentioned. So directly we are going to use s is equal to u of t plus half a t square. Now when this u is 0, because it starts, right, So now for first 10 second, S1 that is equal to half of A 10 square. For next S2 that is equal to half of A 20 square. Right. So taking ratio, can I consider this is equation 1? Can I consider this is equation 2? So S1 by S2 that you are taking 10 into 10, right, by 20 into 20. Okay. So 4S1 that is equal to S2. This is a correct relation. It is going up. The B is the perfect answer for this specific question. Right. The simple use of the equation. I'm moving aside. Simple use, right? The distance traveled by the particle starting from the rest and moving with the acceleration of 4/3 in the third second will be what? Starts from t is equal to 0. We want to calculate the distance at 3 seconds. Acceleration, it is moving, it's 4/3 meter per second and square, and it is constant. It is a constant. It means we can apply the equations of the uniformly accelerated motion. It starts from rest. It means initial velocity is 0. Directly we are going to use this equation. S is equal to ut plus half at square. Right? U is 0. S is equal to half. Acceleration is 4/3 into 9. 3 is a 2 2s are, S is equal to 6 meter. The total displacement with respect to the reference point is 6 meter. C is the perfect answer. Sir, sums are going to be quite simple. Don't get worried. Whatever the 30 questions are included into the DPP, they are rapchik sums. To clear out the concept and the basics, right, it is important. Car accelerates from the rest at the constant rate alpha, right, which decelerates at the constant rate beta and comes to rest. If the total time elapsed is d, then the maximum velocity will be what? This is a very nice question. What it states? It starts with t is equal to 0 from rest, u is equal to 0. It is getting accelerated by alpha. It means velocity from 0 is slowly getting increased to max for time t. Now what happens? Slowly it is getting, right, decelerated by beta, and after time 2 again the velocity is getting 0. Start from rest, reaching up to maximum value, it will take time t1 and getting accelerated by alpha. Slowly it gets decelerated by b, and the velocity from max, it is again coming back to 0. So in summarized form, it started from rest, reached up to the maximum value, again it comes back to the rest. In this case, we need to calculate the value of the maximum velocity. Now what is the total time? Total time. Time of the acceleration is t1. Time of the deceleration is t2. Journey is over. The total time is t1 plus t2, and that is t. Can we use the first equation of the motion here? V is equal to u plus at for time interval 0 to t1. Can we say final velocity is Vmax, initial velocity is 0, acceleration was alpha, time is t1. So can I say t1 that is equal to Vmax, right, whole divided by alpha. Can I consider this as equation number 1? Yes, I can consider this as equation number 1. When it returns back, first when it was moving forward, the velocity was increasing. Now let's apply the equation again. V is equal to u plus at. Now when it returns back, initial velocity is Vmax, final velocity is 0. Initial velocity is Vmax. It is getting decelerated. Beta is a deceleration, right? Alpha is an acceleration. Acceleration is having the positive sign, deceleration is having the negative sign. So it is T2. T2 you are going to get it as Vmax by beta. Total, can I consider this is equation number 2? Total time is T. So T is equal to Vmax, right? 1 by alpha plus 1 by beta, right? So Vmax you are going to come upon as alpha beta of T whole divided by alpha plus beta. This is the value of the maximum velocity. D is the perfect answer, right? I'm moving aside on the countdown of 5 seconds, 10 seconds, you can check it out. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. A body particle moves into the straight line with a constant acceleration. Its velocity, right, changes from 10 to 20 while passing through the distance of 135 in t second. Value of t is what? S is 135, right? 10 to 20. V is 20, U is 10. First of all, yes, use the third equation of motion, right, to find out the acceleration, right? It's 400 minus 100 whole divided by 2 into 135, right? The acceleration it is going to come upon as 300 whole divided by 2 into 135, right? So it's 215 into 10 are 15, 9 are 135, right? Acceleration it is going to come upon as 10 by 9 meter per second square, right? What is the time t? Simple. Again, we are using the first equation of motion. V is equal to u plus 80. 20 minus 10 is equal to 10 by 9 into t, right? T is equal to 9 seconds. It is coming upon as the answer. In the span of 9 seconds, right, this parameters are getting changed. Body starts from red. What is the ratio of the distance traveled in 4th and 3rd second? Here comes the new formula for the displacement into the nth seconds. The displacement into the nth second is given by right. It starts from rest. U is equal to 0. The formula of the displacement of the nth second, it is a by 2 2f n minus 1, right? Okay, u is 0 in 4th and 3rd second. Into the 4th second, it's a by 2, 2 into 4, 8 minus 1 is 7. In 3rd second, a by 2, right, 2 into 3, 6 minus 1 is 5, right? So it's 4th by 3rd second. So s 4th by s3, that is equal to 7:5. A is the perfect answer for this specific question, right? I'm moving aside. See, this is how simple they can be, right? So I'm moving aside on the countdown of 10 seconds. You can move. Particle moves a distance x in a time according to the equation. See now here, one motion parameter is depending on another, then immediately you should all have a click, right? That the calculus method is going to use. Particles move distance x is equal to t plus pi whole to the power minus 1. 1 whole divided by t plus pi. X value is this. The acceleration of the particle is proportional to. See, whenever you have to move on from displacement to acceleration via velocity, always do differentiation. Whenever you have to move on from acceleration to displacement, the reverse process, via velocity, you have to do integration. In integration are of the two types, definite and indefinite, right? So whenever you are doing the integration, the initial values, the constant values are needed. Okay, I think I will show you all into the graph based question. Don't get worried. So x is equal to 1 by del. Let's differentiate with respect to time. velocity is equal to dx by dt, that is equal to minus 1t plus pi whole to the power minus 2. Again differentiate this with respect to time to get the acceleration. It is dv by dt, that is equal to 2t plus pi whole to the power minus 3. Here acceleration in with respect to time we got, but in option it is shown acceleration with respect to distance or velocity we need to mention. So what we are going to do, right, what we are going to do, we are going to follow the very simple approach, right. What will be that simple approach? Acceleration, that is equal to 2t plus 5 whole to the power minus 1 multiplied by 3. Can I replace velocity here? Right. Velocity will be half of, right, that will be minus 1, it's okay, it is directly proportional to t to the power, right, of minus 1. Replacing it here, acceleration is directly proportional to t to the power 5, I'm sorry, velocity whole to the power 3 by 2. This is the dependency of the motion parameters, right. This is the dependency of the motion parameters, and this is a way, right. Smartly you have to apply the calculus method, but don't get worried. In the graph conversions, I will give you all the Brahmastra of the calculus method. Right, into the graph conversion, I'm going to give you all the Brahmastra of this. Now see, particle moving along the x-axis has the acceleration f, and the time is given by this. See, equation of the acceleration, it is given as f is equal to, right, f of 0, 1 minus small t by capital T, right, 1 minus small t by capital T, where f0 and capital T are the constants. Particle at t is equal to 0 as a 0 velocity, right. What will be the particle velocity in between the time interval t is equal to 0 and when f is equal to 0? Acceleration is given, we have to reach up to the velocity, then one thing is sure, we have to do integration, right. But in what time interval we have to do the integration? In between t is equal to 0 and f is equal to 0. So first of all, what we need to do, we need to define the value of t when f is getting 0. So when f is getting 0, right, 1 minus t by t. So small t is going to get equivalent to t. So we need to define the velocity in between the time interval t is equal to 0 to t is equal to capital T. Right. So can I say dv by d of t, that is equal to f of 0, 1 minus small t by capital T. So dv is equal to f of 0, right, minus f of 0 of t by t, right, okay, into d of t. Can I integrate this? Right, that is f0 of dt, right, limiting from 0 to capital T, minus f0 of small t by capital T, integration 0 to capital T dt, right, 0 to capital T dt, right. So here this is the thing I was telling about. Whenever you are doing the differentiation, no limits are needed, but whenever you are having the integration, limits is needed. Else what is going to happen, right, you will have the constant term. If limits are there, then this is the case of the definite integrals. If limits are not there, then you are going to get into the mess, right. So this is going to be f0 of t minus f0 of t by 2. The velocity will be f0 of t by 2, right. This will be the perfect answer for this specific question and the perfect use of the calculus method, right. Displacement of the particle depends on the time by the equation. See, one motion parameter depends on another motion parameter, and the change we are not able to define. Immediately we are going to use the calculus method. The displacement of the particle when velocity is zero. Displacement of the particle when velocity is zero. First of all, let's obtain the equation by rearranging the term. X we are going to get it as t minus t square minus 6t plus 9. This is a dependency of the position with respect to time. What we need to calculate? We need to calculate the displacement when velocity is zero. First of all, let's differentiate with respect to time to get the equation of velocity. Velocity is 2t minus 6 is equal to 0. At t is equal to 3 seconds, we are getting the v0 velocity. Then what will be the value of the displacement at t is equal to 3 seconds? The same thing it is asked now. When velocity is 0, calculate displacement. At what time velocity we are getting 0? T is equal to 3 seconds. Replace in this equation to get the value of displacement. 9 minus 18 plus 9. 0. This one question is homework from my side. You can answer beneath the video, right? Okay, you can answer beneath the video. Okay, now we are going to move forward on to the next concept. Now see, the graph based questions, right, for all kind of the motion and the motion under gravity and the relative motion, these things are remaining. Okay, we are going to cover between 3 and 3.5 hours of this lecture, right? So let's move on to the next concept of, right. Graph fundamentals. So till now in this lecture we have seen the fundamentals of the motion into the 1D, and then we move forward to the the motion parameters, and then we move forward to the concepts of the uniform motion, and then we move to the uniformly accelerated motion. Now we are directly moving forward to the graph fundamentals. Now how much part is remaining? Graph fundamental is remaining, and after that we will deal with the motion, the gravity cases, okay, and at the end with the relative motion. Okay, so relative will be the awesome thing. Now let's move on to the graph fundamentals. What does it states? Okay, before moving on to that much part, okay, I want to tell you all about, okay, we need to discuss some stuff, right, and that even into the detailed manner. Okay, first of all, before moving on to that much technicalities, first we will move on to the some of the basic things. What is the slope of the graph? What is the area of the graph? How slopes are defined? How areas are defined? So first of all, if I'm talking about the slope, right? See, suppose here we are having the graph. On the y-axis we are having any physical quantity. On the x-axis we are having another physical quantity. Right? Now the graph is a straight line subtending theta, right? Okay, this theta is in anti-clockwise direction with respect to the positive x-axis. Is in anti-clockwise direction with respect to the positive x-axis, right? So here in this case, how we are going to define the slope? Slope that is equal to tan of theta, that is equal to del y by del of x. In graph, any quantity that is on the y with respect to x always gives up the slope. This thing you all are aware of, right? It always gives up the slope. Right? Now, let's move on to the next thing. Suppose if the graph is curved, then how you are able to calculate the slope? Okay. Suppose this is y versus x graph and it is a curve. You want to calculate the slope at the single point xy. what you have to do, you have to draw the tangent. If the curve is crossing through single point, right, then draw the tangent. This tangent will give you the idea of the slope, right? This tangent will give you the idea of the slope. So slope here, it is going to be dy by dx, and that is equivalent to tan of theta. Suppose if the graph is crossing through 2 points, right? This is x2 comma y2, this is x1 comma y1, right? The curve is crossing through the 2 points. How you are going to identify the slope in that? If it is crossing through 1 point, draw the tangent. If it is crossing through 2 points, draw the secant. This is all you have seen into the basic mathematics, right? Okay, draw the secant, right? This will give you the idea of the slope. Okay, this will give you the idea of the slope. Okay, so when crossing through the 1 point, draw the tangent. When crossing through the 2 points, draw the secant. Okay, so here we are going to have it as y2 minus y1 whole divided by x2 minus x1, that is equivalent to tan of theta, and that is equal to slope. This is how things are going to get calculated. This is how slope is defined in each and every graph. If it is a curve, right? If it is a parabola kind of thing, directly you can move on, right? If it is not in parabola, an irregular curve crossing through more than 1 points, then you can draw the seconds, right? Okay, and lastly, for the straight line, you can calculate the slope, right? So this was the first fundamental of the graph, that is known as slope. Let's move on to the next one. Okay, question solving approach, it is one and the same thing, but first of all we are going to see, right, the things into the graph, and we are going to see into the graph conversions. Okay, now how you are going to calculate the area for the symmetric and the asymmetric graphs. Suppose this is a graph, one physical quantity on the y-axis, the second physical quantity is on the x-axis. Now what is going to happen? Suppose the graph is like this way, right? Then what will be the area under the graph? Area under the graph will be this much area that has been, right, shaded. Area shaded under the graph, that will be equivalent to, right, the area of the symmetric shapes. Here rectangle may appear, right, triangle may appear, right, anything may appear. So area, and that will be obviously equivalent to y del x, right? That will be obviously equivalent to y del x if it is of the symmetric shape. How to calculate the area for the asymmetric shapes in between the two limits, right? How to calculate the area into the asymmetric shape? Let us take another example of the graph, right? This is the y-axis, this is the x-axis. Suppose the graph is like this way. Okay, the nature of the graph is kind of the parabolic or a kind of a curve. Generally, parabola is used to, right, take as an example. Why? Because students used to get, right, easily used to get with it, right, easily used to get comfortable with it. So that's why the parabola is used. But in this case, okay, you can consider it as a curve also, right? So here, how you are going to calculate the area? First of all, define the two limits. Suppose this is an initial limit, right? Okay, this is a final limit, right? So through the drawing of the tangent by slope, we will get relation between y and x. By slope, we will get the relation between y and x. So what happens here, right? Area, that relation we are going to replace in this equation for the curve. And what will be the limits? Limits will be from x of initial to x of final, right? So by this equation, how much amount of the area we are getting? Okay, the region that is shaded here. Okay, so this is how you are going to calculate the area into the symmetric shapes, right? And this is how you are going to calculate the area into the curves. Okay, so these are the two most important fundamentals of the graph. Okay, these are the two most important fundamentals of the graph. Now we are going to see, okay, what are the graphs of the uniform motion? What are the graphs of the uniformly accelerated motion? What are the graphs of the non-uniform motion? Okay, all of those things we are going to see, and after that we are going to deal with all of those sums, right? Okay, before moving on to the graph conversions, let's see all of those graphs first. The graphs of uniform motion. Graphs of uniform motion. Okay, what does it states? Uniform motion means it is a very simple thing. Velocity of the particle is constant, or you can say speed is constant. Okay, so it means that its position versus time graph is going to be like this way, right? In which this is a slope and that slope is constant. The velocity versus time graph is like to be this way because it is a uniform motion, constant. Now as this is a rectilinear motion, so we can say the speed and velocity both are constant. Generally, if we are talking about the motion in the 2D, right, then we can't say the velocity as a constant, we have to say speed as a constant. But here, as we are dealing with the motion on the rectilinear path, right, we can say the speed and velocities are constant because the direction of the velocity is not going to change in that. Okay. If it is going to change, then the graph is going to appear on the negative side. What will be the acceleration versus time graph? Right, this will be 0. Acceleration versus time graph will be 0. Yes or no? Right. Okay. Now, second will be the graph of uniformly accelerated motion. Uniformly accelerated motion states that, right, acceleration of the particle is kept constant. Right. Acceleration of the particle is kept completely constant. So here on the right side, I'm going to write it as acceleration constant. So what will be position versus time graph? Let's say particle starts from rest. Right, if it starts from rest, can I write it at x is equal to u of t plus half of a t square? Suppose it starts from rest, can I say x is equal to half of a t square? Can I name it 1? Can I name it 2? Right? Okay. Suppose, see, first of all, if we are taking it as a rest, then we are able to understand the actual nature of the graph. Right? The actual nature of the graph. X is equivalent to half at square. Acceleration is constant. It means x is directly proportional to t square. We are having this kind of the parabolic curve. Right? This thing you have seen into the basic mathematics, x is directly proportional to t square. Right? X is directly proportional to t square. Okay. Now suppose this is a second curve. Suppose if you want to plot it up, x is equal to ut plus half at square, in which ut will be always, ut will act like an intercept that acts into the straight line, right? Okay, will be the fixed value, right? Then the graph is going to appear like this way, this, right? Okay, I'm sorry, graph appears to be like, just hold on. Okay, I'm sorry for that. Okay, graph appears to be like this way. This will be u of t. This is the first graph, right? Acceleration is a constant, and depending on the three equations that we obtain into the cases of the uniformly accelerated motion, we plotted up the graph. Okay, now the second equation is of v is equal to u plus at. I am naming it as a 1. Second, suppose u is 0, then v is equal to at. V is equal to u plus at, right? It means we are having u as the intercept, right? We are having u as the intercept. So directly we can say the first graph would appear like this way. Okay, this will be the u intercept, and this is how the velocity is increasing. This is a fix, right? Beyond this, the velocity is increasing with respect to time. Okay, what about v is equal to 80? This will be the first graph. This will be the graph of v is equal to 80 if it starts from rest, right? If it starts from rest, so this will be the second graph. Okay, so this is how the graph for the velocity versus time into the uniformly accelerated mode. If velocity is increasing with respect to time, then graph is a straight line. If it is decreasing with respect to time, then we are having the negative slope. Here we are having the positive slope, right? Here we are having the positive slope, but when the velocity decreases with respect to time, we are having the negative slope. Velocity decreases with respect to time, we are having the negative slope. Lastly, what will be the acceleration versus time graph? The third graph. Acceleration is constant, right? So either it can be positive, that is acceleration greater than 0, or we are having the negative acceleration, that is acceleration less than 0. But the value is going to be get constant. The value is going to be constant, right? So these are the graphs of the uniform motion, right? The next one, it is a graph of the uniformly accelerated motion. I'm moving aside on the countdown of 10 seconds, right? If you want to just note this down, you can note it up, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's it. Okay. Now, the basics of the graph we saw, right? The fundamentals of the how to calculate the slope, how to calculate the area, right? We saw. Okay. After that, we dealt with this thing, what we can say, the types of the graphs. Now we are actually moving forward to the graph conversions, right? We are actually moving forward to the graph conversion. Now, what does it state? What is a Brahmastra of graph conversion? First of all, we are going to deal with the entire theories of the graph, right? In some of the resources, there are thousands of books are having plenties of, right, graphs, xt, speed, time, position, time, like this and that, and okay, unnecessary list of graphs are given. I'm not saying the content is not useful, right? Content is useful, but basically it is creating a high impact on your mind. Okay, basically it is creating the high impact on your mind. Okay, so that differs. That thing differs. Okay, that thing differs, right? So yeah, graph conversion. What is the Brahmastra of the graph conversion? The Brahmastra of the graph conversion is fundamentals of graph plus calculus method, right? Fundamentals of the graph plus calculus method. This is a Brahmastra of the graph. Right. How? In calculus method, we are having only three simple formulas. One, that is A is equal to V dV by dx, right? Second is equal to A is dV by dt, right? And V is equal to dx by dt. Fundamentals of the graph, right? Always see in the sums of the, I'm going to show you all the sums of the graph conversion. Okay, how I am saying this, right? And why I am saying this, it is important. Okay, so for that, let's solve some of one example. Suppose, right, the V versus X graph is given. V versus X graph is given. The question states that, okay, make the appropriate A versus X graph. In some of the questions, right, as we are dealing with the MCQ, so they might be having the four options also, they might be given, right, there might be given the four options, okay, but how to reach up to the exact answer, that is important. Okay, see, immediately we can say this is a graph with a straight line. Okay, so the step one is identify the nature of the graph, whether it is a straight line, it is a curve, right? What kind of the curve? It is a parabola, hyperbola, ellipse, right? Okay, this all thing, it is a circle, all thing you all are aware of. Okay, what is the equation of the circle? What is an equation of ellipse? Okay, what is an equation of the parabola, kind of parabola, hyperbolas? Okay, the equation of the straight line you all are aware of. So first step is identify the nature of the graph. Question solving approach I am writing here. Okay, first step, identify the nature of the graph. What will be the second step? Obtain the relevant equation based on the nature. Obtain the relevant equation from it. This is a graph of the straight line. Okay, it is having the intercept, so it means immediately, right, it should be clicked that we are going to follow the equation y is equal to mx plus c. On y-axis we are having physical quantity velocity. On x-axis we are having the physical quantity, that's x. Intercept is v0. What about the slope? Okay, you let's change one value. Let's have intercept as u. This will be v0 and this will be x0. Right. Okay. So what is the slope of this graph? Right. The high is v0 minus u whole divided by x0. So here we are going to get it as v0 minus u whole divided by x0. So according to y is equal to mx plus c, we obtain this equation. Again, I am rewriting v is equal to v0 minus u whole divided by x0. Right. If you don't want to make that much complex at the initial level, right? Okay, you don't want to make things, right? Then you can remove the intercept. Right? You can remove the intercept. If you are removing the intercept, things are gonna be quite easy. Suppose the graph starts like this way. Okay, then y is equal to mx plus c, right? Obtain the relevant equations of it. Okay, y is v, slope is positive v0 by x0, right? Okay, we are having x plus no intercept. Okay, no intercept, right? Can I consider this equation number 1? So step 2 successfully completed. Step 1 was identify the nature of the graph. Step 2, obtain the relevant equation from its nature. Okay. Step 3, use the calculus method. use the calculus method. Now suppose we obtain the relation, right, v versus x, right? So this is the given data. Now what we have to find out? Try to identify how to reach from v to a via x using the calculus method, right? So we are having only the three formulas of the calculus method. A is equal to v dv by dx, right? A is equal to dv by dt and v is equal to dx by dt. Anyhow, see, if you have to move from displacement to velocity, velocity to the acceleration, anyhow you have to do differentiation. If you want to follow the reverse phenomena, then you have to follow the integration. So one thing is fixed. We have to move from velocity to acceleration. It means we have to follow the differentiation. But it is important to select the correct formula from the calculus method. So we have to move from v to a via x. This is only the method that can be useful. Sorry, this is only the formula that can be useful. Let's see. Okay. So let's differentiate with respect to x. Okay, so it is dv by dx, that is equal to v0 by x0, right? This is not acceleration. Consider this is equation number 2. Acceleration is a is equal to v dv by dx. Replacing the formula of v, replacing the formula of dv by dx. So you are going to get v0 by x0 into x into what is d? v0 by x0. So acceleration equation is v0 square by x0 square into x. Here v0 and x0 are constants. v0 and x0s are kept constants. Yes or no? Do you got this stuff? Everyone, those who are live, do you got this stuff or no? Now, step 4 we successfully completed. The last step of the graph conversion, right? Okay, this was the 4th. On basis of equation we obtained from calculus method, select the correct graph. Select the correct graph. It means it is very simple thing. We obtain the equation, just mark my words, right? Equation is a is equal to v0 square by x0 square into x. This is a constant term. Can I say a is directly proportional to x? It means it is a graph of this straight line with zero intercept. Just the slopes are getting different. This is a versus x, right? This is a graph, right? This is a theta here. The slope that will be equivalent to v0 square by x0 square, right? This is the a versus x graph with the zero intercept, right? Okay. Here the slope is v0 by x0. This is only the straight line graph. Here also we are getting the straight line, but the slope is v0 square by x0 square. There is a difference of slope in between these two. Okay. This is the actual phenomena of the graph conversion. Okay, so students, first of all, let's summarize this thing into the right? Step 1, identify the nature of the graph. Step 2, obtain the equation based on the specific nature. Step 3, apply the relevant calculus method. Step 4, obtain the relation, right? This is a relation where we have to reach, and that relation that has been asked in the question, right? After reaching up the relation, identify whether it is the relation matches to the equation of the straight line, whether this relation matches to the equation of the ellipse, whether this relation matches up to the equation of circle, right? Then draw the appropriate graph of it. This is a very simple phenomena of the graph conversion, right? A very simple and appropriate phenomena of the graph conversion. Yes or no? Okay. Now, let's see some of the sums based on it. Okay, some of these sums. We are going to see some 7 to 8 sums, right, on the basis of the graphs and the graph conversions, right, on the basis of the graph and the graph conversions, right. So, are you all ready? The particle shows the distance time curve as given into the figure. The maximum instantaneous velocity of the particle around the point will be what? Maximum instantaneous velocity. See, first of all, I'm giving you all a 10-second to, right, watch the stuff to pause this video, right, and try to solve it. It's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Particles show the distance versus time graph, and we see from distance anyhow we have to reach to the velocity. It means anyhow we have to deal with the slopes, because anyhow ratio way of distance to the time is going to help us in reaching the instantaneous velocity. Suppose if I'm talking about point A, right, we want that point among A, B, C, D, right, where the instantaneous velocity is maximum. I told you all into the fundamentals of the graph. Graph is crossing through the multiple points, but we have to analyze each point individually. Graph is crossing through multiple points, right? We can select any of two and draw the second. But the question states which point among four has maximum instantaneous velocity. So it means that each and every point should be analyzed individually. So for that we have to draw the tangent. Suppose if I'm talking about the B, right, draw the tangent. This is the angle theta B is making. If I'm talking about the C, right, and if I'm talking about D, where you are going to get, okay, the maximum intensity, the point where the slope is maximum, right, we have dx by dt, that is equal to maximum. When dx by dt is equal to maximum, we are having instantaneous velocity to be maximum. Dx by dt to the maximum, we are having instantaneous velocity to be maximum. Dx by dt to the maximum, we are having instantaneous velocity to be maximum. Yes or no? Okay, so here you can understand as compared to B and D, the theta C is, right, the angle theta C is maximum. So on basis of the value of the theta C, we are having tan theta C value as the maximum. Okay, so C is the perfect answer for this specific question where we are having the maximum value of the instantaneous velocity, right? Maximum value of the instantaneous velocity. So let's move on to the next question onto it. The displacement time graph of the moving particle is 0. The instantaneous, see again the displacement time graph came. Now this time instantaneous velocity of the particle is negative at. It is displacement versus time graph. Immediately it should get click into the mind. Where? See, the slope of the displacement versus time graph is an acceleration. Sorry, velocity. So wherever we are going to get the negative slope, that point is our answer. Okay. So 4 points are given. Obviously, right, we have to analyze each and every point individually. So we are going to draw up the tangent. Here at C, the theta is acute. If theta is acute, then the tan of theta is going to be the positive value. Theta is acute, then tan of theta is going to be the positive value. Right? Tan of theta is going to be the positive value. D. Theta is 0. Slope is 0. Instantaneous velocity is 0. F. Theta is acute. Tan theta is positive. Instantaneous velocity is positive. Right. E. This theta angle is always calculated in anti-clockwise direction with respect to positive x-axis. Okay. Anti-clockwise direction with respect to the positive x-axis. It means that with respect to positive x-axis, this I am going to theta in the anti-clockwise direction. Then at position E, right, theta is obtuse. If theta is obtuse, then tan theta value will be negative. If tan theta value will be negative, then slope will be negative. If slope will be negative, then instantaneous velocity will be negative. Right? Slope will be negative, instantaneous velocity will be negative. Okay, so here the E is gonna be perfect answer for this specific question. E is gonna be perfect answer for this specific question. Let's move on to the next question onto it. The variation of the velocity versus the velocity of the particle with time moving along the straight line is illustrated in graph. What is the total distance traveled by the particle in first 4 seconds? Velocity versus time graph. Area under this gives distance displacement. Slope under any symmetric curve gives acceleration. This is VT graph. Right? In VT graph, it is a very simple thing. Area under graph will give distance. Area under graph will give distance. Right? Yes or no? Okay. So how to calculate? This is area A1. This is area A2. This is area A3. This is area A4 and this is area 5. So the total area under the graph in between 0 to 4 seconds. Total area under the graph in between 0 to 4 seconds will give, right, the actual value of the distance of the particle. So can I say distance between 0 to 4 seconds is equal to total area. Right? So total area is A1 plus A2 plus A3 plus A4 plus A5. A1 is triangle. So it is half base into altitude. So it's half 1 into altitude of 20 plus A2 is 1 into 20 plus A3 is half into 1 into 10 plus A4 is 1 into 10 plus A5 is 1 into 10. So this is gonna be 10 plus 20 plus 5 plus 10 plus 10. Right? So this is gonna be 20, 50, 55 meter. The total distance traveled is 55 meter. And B is the perfect answer for this specific question. Total distance traveled is 55 meter and the B is the perfect answer for this specific question. Yes or no? Graph conversion. The Vx graph of a particle moving in the straight line is shown below. Which of the below graph shows A versus X? See, we have seen with the positive slope. Here comes the thing with the negative slope. V versus X graph is given. We need to select the correct A versus X graph. Step 1. Identify the nature of the graph. Straight line. Step 2. Obtain the relevant equation. According to the formula, y is equal to mx plus c. On y-axis, we are having velocity. Slope. Theta is obtuse. Right? Slope will be negative. So it is negative of v0 by x0. On x-axis, we are having x plus. This is the intercept v0. Second step successfully completed. The first step, we identify the nature of the graph, that is a straight line. Second step, we obtain the relevant equation. Now third step, we have to use the relevant calculus method. Equation is x naught x plus v naught. We have to reach from velocity to acceleration via displacement. So it means anyhow, right, A, okay, we have to use the formula A is equal to V dV by dx from the calculus concept. Let's differentiate this equation with respect to x. So it's dv by dx, that is equal to negative of v naught by x naught. Can I consider this as equation number 1? Can I consider this as equation number 2? Right. From this, we are going to obtain the equation of the acceleration. Acceleration is equal to v dv by dx, right? So that is equivalent to negative of v naught by x naught of x plus v naught, right, into, right, negative of v naught by x naught. So resolving this, you are going to get v naught square by x naught square of x negative of v naught square by x naught. If you are analyzing this equation, anyhow, A is equal to mx minus c is there. Relation of acceleration and your displacement, x is having only one power. It means it is going to come the equation of the straight line, right? Only either like the slope may differ or any kind of the there will be the change into the values of the intercept. So this is going to follow the y is equal to mx plus c. Right, this is going to follow the y is equal to mx plus c, right? But here we are having the positive slope. Intercept is negative. Negative intercept, v naught square by x naught. Slope is positive. See, with respect to the positive x-axis, theta is acute. If theta is acute, slope is positive. This will be the perfect A versus X graph. So what we did, step 1, identify the nature of the graph. Step 1, obtain the relevant equation. Step 3, try to find out which formula from the calculus method we are going to use. Step 4, apply the relevant right formula and get the equation. Step 5, from the equation, identify what will be the nature of the graph. That has been asked in question. What will be the nature of the graph? That has been asked into this question. Yes or no? D is the perfect answer for this specific question, right? D is the perfect answer for this specific question. Is it cool? Let's move on to the next question onto it. A ball is dropped, the displacement versus time graph is shown. right? Okay, this is right, the thing that is going to come up into the work energy and power also, so we are leaving it here only. Okay, so this was, or you can try it into this homework. This is the second homework based question I'm going to give up you all. The first was given yesterday. Okay, this is a homework from my side. Okay, this is the homework from my side. Okay, we can try, or else we are going to see this question into the work energy and power also. Now let's move on to the motion under gravity case. Okay, motion under gravity is quite simple. When object is, right, thrown or released from some, okay, what does this Galileo stated? The Galileo stated that when two objects, irrespective of the masses, released from top of Leaning Tower of Pisa, they are accelerated by constant value towards the center of Earth. The motion of the particle as because of this kind of the constant acceleration is defined as motion under gravity. Motion of the particle as because of this kind of the acceleration, it is known as motion under gravity, because this acceleration is gravitational acceleration as because of the Earth, whose value is g is equal to 9.8. okay, whose value is g is equal to 9.8. 9.8 meter per second square. Yes or no? 9.8 meter per second square. Yes or no? In motion under gravity, what will be the question solving approach? See, only two things are going to be useful into the case of the motion under gravity. The first thing that will be this one. What we can say? Sign conventions, and the second one in question solving approach, like for this, right, is the appropriate use of the equation. First of all, in the case of the motion under gravity, I'm going to write some noteworthy points. The acceleration is always negative. Air resistance is completely avoided. There are some cases in which the air resistance we are going to, right, like it will be taken into the consideration, but right now for maximum number of the cases, let's avoid this air resistance. Okay, let's avoid this air resistance. So air resistance is completely neglected. A is equal to negative g, right? Object is thrown, always it is thrown less than the escape speed of the Earth. It is always thrown less than the escape speed of the Earth. Always. Right? It is always thrown less than the escape speed of the Earth. Right? And apart from this, if it is thrown less than, okay, the curvature effect of Earth is always avoided. For maximum number of the cases, as we are dealing the motion in the straight line, right? For kinematics, A will be of negative g. The value of g is not changing, right? The value of the g never changes. Okay. Now, this was the first most important part regarding the motion under gravity. Okay. The next most important point that we are going to deal with, these sign conventions. Always see, for sign conventions, I already told you all. If the vector is acting into the downward direction, right? If we are taking it as a negative j, it will be negative. If the vector is acting into the upward direction, we are taking it as a positive j, it is positive. If the vector is directing towards the positive x-axis, then we are a positive I. If it is directing towards the negative x-axis, we are having the negative I. Okay. So these are the same kind of sign conventions we are going to use, and I told you all into the the previous part of this session also, the sign conventions are always applied with respect to the reference point, and into the cases of the motion into the straight line, t is equal to 0 will be our reference point, right? T is equal to 0 will be our reference point. Okay, t is equal to 0 will be our reference point. Now, in case of the motion under gravity, a is equal to negative g is there. Why? Because gravitational acceleration always acts into the downward direction. In some of the resources, they mention that downward is taken as positive, upward is taken as negative. All of those relevant equations are going to form. Don't get worried. But it is important, right, to follow the approach that we are going to use into the entire syllabus. It is important to follow the approach. So for that reason, always I am taking downward as the negative and the upward as positive. A is equal to negative g. Obviously, it is going to be the constant value. Right? It is going to be the constant value. Yes, it is going to be the constant value. So it means that we can apply the equation of the uniformly accelerated motion. V is equal to u minus gt. Second, S is equal to u of t minus half of gt square. Third, v square minus u square is equal to negative of 2gs. We have to apply the sign conventions. I have to only apply. Now, first of all, let's see, right, how sign conventions are applied. Then and then we are going to see towards the sum, right? First, how to apply the sign conventions into the multiple cases and how to write down the equation. Suppose object is thrown into the upward direction from the graph. Object is thrown into the upward direction from the ground, right? So here u. Slowly it will move forward. It will reach to the max height and it is going to come down. It follows this straight line, but for the understanding purpose, we are drawing like this, right? So how to write down the first equation of the motion? See, first equation of the motion states v is equal to u plus at. This will be our reference point. T is equal to 0. With respect to this, we are going to apply. V will be the final velocity at the top. 0. Initial velocity is directing into the upward direction, positive. Acceleration is g, that acts into the downward direction, it is negative g. Second equation, S is equal to u of t plus half of at square. With respect to the reference point, see, always whenever you apply the sign conventions, now always I apply the sign conventions, right, in between any 2 points. Generally, it is not even with respect to the reference point. I'm writing now, apply sign conventions any 2 points. Any 2 points you can apply the sign convention. Right now I've taken the ground and the top as a first point. Slowly I'm going to change up the values. Don't get worried. So here S will be positive U will be positive, G will be negative. This is the second equation of motion. Now suppose if I am taking the second case, right, from the cliff, from a tower, object is released. Okay, so this will be the first point, this will be the second point. Between A and B we are going to apply the sign conventions, right? Between A and B we are going to apply the sign conventions. So what is going to happen here, right? V is equal to U minus GT, sorry, U plus GT. G will be negative. Okay, U is 0 because it is dropped. V will be negative because V is acting in this direction. So V is equal to negative of G. So the first equation is going to come upon as V is equal to GT. The second equation is S is equal to UT plus half of AT square. S is negative because it is directing downward. U is 0 plus negative of half GT square. So S is equal to half of GT square. This will be the second equation of the motion. How to write down the third equation? In between initial and final points, right? V square minus U square is equal to 2AS. Final is V square. Initial is 0, 2, negative of G, negative of S. V square is equal to 2GS. This will be the third equation of motion. This is how sign conventions are applied in between 2 points, right? This is how the sign conventions are applied in between the 2 points. Yes or no? Right? Now let's move on to the next question. Let's see some of the sums, right, and see, right, and we will analyze this things, right? Let's see some of the sums and analyze this stuff. Now, a boy standing at the top of the tower of 20-meter height. Ground, tower, height 20 meter. Drops a stone, assuming G is equal to 10. It drops a stone. It means initial velocity is 0. This is a point A, this is a point B. In between the top of the tower and the ground, we are going to apply the sign conventions and get up to the results. The velocity with which hits the ground. See, no data about time is given. Height is given. We have to calculate the velocity, and the initial velocity is 0. Immediately it should we should get a click that we have to use the third equation of motion. V square plus V square minus U square is equal to 2AS. The third equation of the motion that we have to use. Apply the sign conventions in between A and B. U is 0. V is actually negative, but we are having square, so it is going to be positive. G is negative, and with respect to A, displacement is also directing in downward direction, so it is negative. So it is 2, negative of G, negative of S, right? So V square it is equal to 2G of S, or you can say H. 2, let's say G is 10 into 20. So V square it is going to be 400. With 20 meter per second velocity, it is going to hit up the ground. With 20 meter per second velocity, it is going to hit up the ground. Yes or no? Okay. So B is the perfect answer for this specific question. A ball is thrown vertically upward from the ground. It has a speed of 10 meter per second. When it reaches 1/2 of its maximum height, how high does the ball rise? This is a very nice question. First of all, I am giving you all the 10 seconds, right, to solve it up, right? Okay, if you want to 20 seconds, you can just pause this video and move on. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You might have paused this video. Let's give you all another 10 seconds. 0, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. Okay. So, hope so you might have paused this video, right? And a ball is thrown, say from ground. It is thrown upward with the speed of 10 meter per second. It means the initial velocity, it is 10 meter per second. When it has reached 1/2 of its maximum height, suppose here this will be the h max. We are talking about the 1/2 of the maximum height, it is h max by 2. Okay, I'm sorry, it is not thrown with the 10 meter per second, right? When it reaches, it is thrown with u. When it reaches the 1/2 of the maximum height, right, it is 10 meter per second. How high does the ball rise? It means we have to calculate the max height. So it is thrown with u. At half of the max height, we are having 10. At the max height, we are having the velocity as 0. So let's apply the third equation of motion in between A and B and in between A and C. First, let's apply the third equation of the motion in between A and B. V square minus u square is equal to 2as. V square is 10, 100, minus u square we are not aware of. That will be equivalent to okay, rather than to follow that much long approach, right, we can directly use the equation. We can directly apply to B and C also, because here velocity is 10. Okay, we do not want to calculate the initial velocity, we have to calculate the max height, right? Then we are going to apply in between B and C. V square minus u square is equal to 2as, right? For BC, this will be the initial value minus 100. At this max height, the final velocity is 0 minus 2g into s. S is h max by 2. Right? H max by 2 height is covering this is a h max. This is half of h max. So this one is the remaining half. So 2 is gonna get cancelled. Right? H max you are going to get it as 10 of meter. Right? Simple. A is the perfect answer for this specific question. A body drop from the top of the tower fall through 40 meter in last 2 seconds. In last 2 seconds, the total time of fall is t. In last 2 seconds, t minus 2 seconds, right? It covers up the distance of 40 meter. The height of the tower will be what? In last 2 seconds, it is covering up the distance of 40 meter. Can I say height of the tower is h? Right? Can I say height of the tower is h? Yes. It is dropped. It means u is equal to 0. So can I say h? That is equal to half of gt square. Right? H, that is equivalent to half of gt square. Can I consider this as equation number 1? If this is h, this is 40, then this will be h minus 40, right? Okay, h minus 40, right? This will be last 2 seconds, so this will be t minus 2 seconds. So can I say h minus 40, that is equal to half of g of t minus 2 square? Equation number 2, right? Equation number 2, right? So this is equation number 1, this is equation number 2, right? Can I replace 1 in 2? So you are going to get half of gt square minus 40 is equal to half of g t minus 2 whole square. From this you are going to get the value of t. If we are going to get the value of t, immediately we can reach up to the h, right? So this is equal to half of gt square minus 40, that is equal to half of g t square minus 2t plus 4, right? So it is half of gt square minus 40 is equal to half of gt square minus half of g into 2t plus, right, g by 2 into 4. So this is gonna get cancelled. Minus 40 is equal to, this 2 is gonna get cancelled, minus g of t, this 2, right, plus 2 of g, right? Minus 4g minus 2g is equal to minus gt. G is gonna get cancelled. T you are going to get it as 6 seconds, right? T you are going to get it as 6 seconds. We solved it up? Yes, we solved it. So the total time of the journey is 6 seconds. H is equal to, the total time of the journey is 6 seconds. H is equal to ut plus half at square. H we need to calculate, u is 0, half into g into 6 square. H is equal to half into g into 36. 2 18s are, height is 180 meter. The height of the tower, right? The total time we got it as the 6 seconds, right? Total time we got it as 6 seconds. A small mistake we did, right? Okay. Here we are going to get it as 40 minus 4, right? Okay. 40 minus 4. So solving this, you are going to get t is equal to 3 seconds. Half g t square minus 40 plus 4. I'm sorry for that. So t is equal to 3 seconds you are going to get, and here, right, 6 square is not going to happen. It is going to happen as, right, it happens, right? It happens, human error. Okay, so it's 3 square. So h you are going to get it as 45 meter. B is the perfect answer for this specific question. B is the perfect answer for this specific question. Right? Let's move on to the next question onto it. What will be the ratio of the distance traveled by the freely falling body? What will be the ratio of the distance traveled by in the 4th and 5th seconds of the journey? 4th and 5th second of the journey. Directly we are going to use up, right, the displacement for n second formula. Right? So it will be s of 4 by s of 5. It is dropped u plus g by 2. 2 into 4 minus 1. u plus g by 2 into 2 of phi minus 1. U is gonna be 0, freely falling body from rest. G by 2 will get cancelled. 4 2s are 8 minus 1 is 7. 5 2s are 10 minus 1 is 9. B is the perfect answer for this specific question. Right? Displacement of the nth seconds formula. The water drop falls at the regular intervals of the time. This is a very nice question. I'm going to give you all into the homework. Right? You can try it by yourself. Okay? Because now approximately what we can say more than 2 hours and 45 minutes of the class has been gone, and only this thing is remaining, what we can say, the relative motion. So directly we're going to concentrate on it. Okay? Directly we're going to concentrate on it. Let's move on to the concept of the relative motion. Right? Entire concept of relative motion depends on only single statement that we have discussed into the beginning of this session. Right? We have discussed what it states. Nothing in universe is at absolute rest. Nothing in universe is in absolute motion. Nothing in the universe is at absolute rest. Nothing in the universe is in absolute motion. Everything depends on the frame of reference and how observer sees this stuff. Entire relative motion depends on this thing. Entire relative motion depends on this thing. Yes or no? Nothing in this universe is at the absolute rest. Nothing in the universe is in absolute motion. Nothing in the universe is at absolute rest. Nothing in the universe is in absolute motion. So what does the relative motion states? Motion of an object with respect to multiple observers is the relative motion. Right now we are going to see this relative motion in 1D into the very simplified form. Right? Again it is going to come back into the next session about the relative 2D. Again it is going to come back. Right? So what does this relative motion states? Right? How the positions of the observers are getting changed, how things are getting changed, how equations are getting changed, how we are analyzing the motion through the different perspective. Let's take an example to understand this stuff. Right? Suppose there are two cars. This is car A, this is car B. This is moving with 10 meter per second. This is also moving with 10 meter per second. Right? Okay. Both are moving with the 10 meter per second. Right? Both are moving with the 10 meter per second. Let's analyze this thing. Let's change this value. 15 meter per second and 10 meter per second. I am taking 3 observers. First observer is on the ground. Observer is on the ground. Second observer is on A. Third observer is on B. First we are taking observer in ground. I am standing on the ground. I can see A is moving with some velocity, B is moving some velocity. Yes, everything is fine. I am on the ground. I am able to see the reality. The person who is on the ground always sees the reality. Right? So the observer who is on the ground sees the reality. So what is the velocity of A with respect to ground? This abbreviation means that velocity of A with respect to ground. Can I say that this is equal to 15 meter per second? What is velocity of B with respect to ground? 10 meter per second. This is a very simple thing. All the times we have seen this stuff. Let's take observer on A. Now observer is on A. What is the velocity of A with respect to A? 0. Why? Observer is on the A. Car A is moving with 15 meter per second. Observer is also moving into the 15 meter per second. Right? Relatively, they appear stationary with respect to each other. Velocity of A with respect to observer is 0. What is velocity of B with respect to A? Is VB minus VA, that is equal to 10 minus 15, negative of 5 meter per second. What this negative sign indicates? Right? What does this negative sign indicates? See, this is the difference. When the observer is in the ground, they both are moving. A is moving and B is moving with different velocities. But when we are on the A, observer is on the A, the speed of the B is less with respect to A. So what it happens? B is coming nearer. The negative sign indicates B is coming backward. This appears when observer is on the A. It does not appears when the observer is on the ground. Things are different. Let's check what happens when observer is on B. First observer is on the A. I can see I am having more velocity as compared to B. Hey, B, you are coming nearer. Now, let's jump off. Observer is on B. Right? Now, what will be velocity of B with respect to B? 0. Why? Observer is on the B. Car is having the velocity 10 meter per second. Observer is also having the velocity 10 meter per second, and that also into the same direction. It means relative 0. So, they both appear rest with respect to each other. Now, observer is on the B. Hello A. I am coming nearer to you. How? See, velocity of A with respect to B. VA minus VB is equal to positive 5. Right? Okay. Okay. B is here. A is coming nearer. Oh, A, come. So this positive sign indicates A is coming this side. According to the sign convention, this side we have taken as positive. This side we have taken as a negative. So here the negative sign indicates when observer was on A. Right? The negative sign indicates that B is coming backward. It appears that, see, if observer is on A, then it appears that B is coming backward. If observer is on B, it appears A is coming in front. Like that. On the ground, what happens? Both are moving. So that is the difference of the the position of an observer. That's why it has been told nothing in universe is at absolute rest. Nothing in the universe is in absolute motion. Okay, nothing in the universe is at absolute rest and nothing in the universe is in absolute motion. Everything depends on the frame of references. Okay, everything depends on the frame of references. Right? What is a question solving approach? See, in the concept of the relative motion, always two interacting particles are there. Always two interacting particles are there. Always. Right? So this is a step 1. What is a question solving approach for all kind of the? Check it out. Anyhow, acceleration 1 with respect to 0, acceleration 2 with respect to 0. This is there or not? Relatively, if we are having no acceleration, it means it is the case of relative uniform motion. Relatively, none among two is getting accelerated. Relatively, none among two is getting accelerated. Then it is a case of relative uniform motion, in which only one equation we are going to use that we were using into the uniform motion, but this time from the observer's perspective we are going to use it. From the observer's perspective, we are going to use this up. Any two interacting particles are there. V12 is equal to S12 by T. Suppose if A12 is not equal to 0, A2 with respect to 1 is not equal to 0, or A12 is equal to constant, right, or A21 is equal to constant, then this is the case of if any one of the interacting particles are having the acceleration, then this is going to be non-zero. Then this will be the case of relative uniformly accelerated motion. So in that case, A12 or A21 is equal to constant. V12 U12 plus A12 into T. S12 is equal to U12 into T plus half of A12 T square. V12 square minus U12 square is equal to 212 S12. This is how the three equations of the motions are defined, right? This is the same equation we have used, but this time in the relative motion we are using from the observer's perspective, right? In the relative motion we are seeing from the observer's perspective. So in summarized form, if we are talking about what actual the actual thing is identify whether the both of the interacting particles are having the acceleration. See, if both of the particles are having the same acceleration, then this velocity, this relative acceleration is going to be 0, and it will be the case of relative uniform motion. You have to just identify whether the relative acceleration is there or not and apply the relevant equation. Preeti, okay, this is a simple thing. Okay, a bus is moving with the speed of 10 meter per second on the straight road. Bus, it is moving with the speed of 10 meter per second on the straight road. Scooterist, he wished to overtake. He is distance d behind the bus. He want to overtake the bus into the 100 seconds. Okay, that distance it is given as 1 kilometer. With what speed the scooterist should chase the bus? I want to ask you all, right, with what speed, right, what will be the speed of the scooterist so that he can cross distance of 1 kilometer in 100 seconds? Relatively. First of all, let's keep the observer on bus. Right. Check it out. Any of them is having the acceleration? No. A1 is also 0. A2 is also 0. It means A12 is 0 or A21 is equal to 0. It means it is a case of relative uniform motion. case of relative uniform motion. So what is going to happen in case of the relative uniform motion, right? What is going to happen in case of the relative uniform motion, right? Simple equation we are going to see now. Observer is on, this is 1, this is 2. Observer is on 2. So velocity of 1 with respect to 2 is equal to displacement of 1 with respect to 2 whole divided by time. V1 of 2, relatively they have to cross 1 kilometer, it means 1000 meter. In what time? 100 seconds. So this is going to be 10. So velocity of 1 with respect to 2, it means velocity of scooterist with respect to bus, we are going to get it as 10. Okay, in this you have to apply the sign conventions. I have taken everything as positive. Why? Because distance is covering on the right side, positive. Velocity is on the right side, both are having, so it is positive. So never forget to apply the sign conventions that we did into the motion under gravity. So VSB is 10. So VS minus VB is equal to 10. So VS is equal to 10 plus VB. So what is the velocity of scooterist? 20 meter per second. This is how things are getting resolved. Okay, I have given you all the Brahmastra of the, right? Why it is taking the less amount of the time for the discussion? Because I have given you the Brahmastra of the relative motion. Train of 150 meter length is going towards the north direction. Train length is 150 meter. It is going toward the north direction at the speed of, this is the speed of train, that is equal to 10 meter per second. Parrot flies at the speed of 5 in the south, opposite to it. Parrot is flying. This is velocity of parrot, 5 meter per second, opposite to it. On the parrot, the time taken by parrot to cross the road. Any of them are getting accelerated? No. Acceleration of train 0. Acceleration of parrot is 0. So it is a case of the relative uniform motion. Relative uniform motion. It is a case of the relative uniform motion. V1 with respect to 2, S1 with respect to 2 time. Now see, they both are moving into the opposite direction. So one velocity will be considered as the positive, the velocity of the train, and velocity of the parrot will consider as the negative. Right? So here, velocity of train minus velocity of parrot, that will be equivalent to the total distance is 150 meter into time t. Now this is considered as positive 10, negative. Negative of 5 is 150 by t. T is going to be 10 seconds. In 10 seconds, right, parrot will cover up the bus, the train. The D is the perfect answer for this specific question. This is how the questions of the relative motions has been solved. Don't worry, the same thing is going to repeat into the 2D, and we are going to analyze the concept of 1D again into the next session. But this was the thing into the very summarized form for you. Okay. 2 trains, each are 50 meter long. They both are moving into the opposite direction. 1 into 10 meter per second. Second is moving with 15 meter per second. The time to cross each other. Check it out. The relative acceleration of the both is 0. It means it is a case of relative uniform motion. V1 with respect to 2, S1 with respect to 2 time. S1, okay. Both are moving into the opposite direction, right? So velocities will be added 25. Distance. See, 50 this, 50 this. 50, 50, 100. First, they both need to cross each other. First, they will get overlapped. They will cover the distance of 50. After that, To cross each other, they will cover up the distance of 50 because both are having the length of 50 meters. So this will be 100. Answer will be 4 seconds. B is the perfect answer for this specific question. The one, this is homework from my side. Right? Okay, don't get worried. Things are going to come up into the next session also. Right? Okay. So students, it's time to go. Yes, it's time to depart. Right? It's time to depart. So this was everything about the motion into the 1D. Hope so you liked that teaser. Right? It was a part of the headquarter of the PW universe. Right? In headquarters from which we were understanding the concept. See, teaser is for you all. It is just a different approach to analyze the physics through the visualization. Sometimes without visualization, physics always used to get bored up. Okay. So some students might be thinking the teaser is not having any kind of the relevancy with the content. Right? But it is just for, it is an initiative to understand the actual concept of physics, what actual the physics is all about. And what truly the each concept states into the form of the visualization. Okay guys, so hope so you like that teaser. I will be waiting for all of your comments beneath the video. This is Indrajit Singh signing off from the desk. Right, again we are going to come back into the next session. Bye bye, Sat Sri Akal and Namaste from my side, Bacha ji. Bye everyone, stay at home, stay safe, stay healthy amidst this pandemic. Bye Bacha ji.